Okay, Assalamualaikum. So I'm Dr. Wan Shahidah. Okay. So the next subtopic for the chapter 6 here is 6.2 contingency table. Okay, so the outcome here by the end of this topic, you should be able to test two variables for the independence using chi-square test, test proportion for the homogeneity using chi-square test. Okay, so both it is about contingency table with different hypotheses. Okay, so because of both are contingency table, by using similar test, which is a chi-square test, then the step how to get the chi-square critical value decision are the same. Okay, the difference between these two hypotheses, it is on your hypothesis, the step 1 and the conclusion lah, the step 5 because conclusion follow your hypothesis. But step 2, 3, 4, it is similar. How do you find the chi-square similar? How you calculate, how you find, or what is your critical value similar? Decision also similar, and still here decision is based on right-hand task. Okay, because it is similar test, which is a chi-square test. Okay, so what is contingency table? So contingency table, it is a data. The data that you have, it is a combination of the row variable and column variable. Okay, so we have row variable and column variable. That's a contingency table. Okay, so contingency table is called an R times C contingency table. So R represent the row, number of row. Okay, so the I here represent the R. So R is a number categories for the row variable. So the number of the category for the row variable. Okay, so I here represent the R. Okay, column variable, okay, represented by the J. So J is equal to the 1 until C. So C is a number of categories for the column variable. Okay, so what variable here? Always be the row variable, and the variable here always be the column variable. Okay, so we have I represent row, we have J represent column, and then we have the data. Okay, so the variable here, okay, row and column here, it is a qualitative variable. Okay, as we know, chapter 6 here, it is about qualitative variable. Okay, so column and row here, they are qualitative variable, and then we have the data here that represent a combination between row and column. So the data here, that's your observed frequency. Okay, so the first data represented by the 11, 011, 011. The first number here represent I. Second number here represent J. So in general, it is a OIJ. Okay, I row, J column. Okay, so first row, first column, that's why you have 011. First row, second column, 012. So in this case, this example, we can say that the R equal to 2. Small r equal to 2 because we have two categories for the row. And the C here equal to 2. We have two categories for the column 1 and 2. Okay, so here we have second row, first column. That's why you have 021. Second row, second column, and then you will have 022. Okay, and this is a summation value Ni dot. It is similar as a one-way ANOVA. Okay, one-way and two-way ANOVA. So Ni dot. So it is a summation of the row. So N1 dots, dot here means that summation. So summation of the first row. So 011 plus 012. Then you will get your N1 dot. Okay, I think it will be clear when we go to the exercise later lah. Okay, but here I will explain. I just explain lah. Okay, so N2 dot, it is a summation for the second row here. So O21 plus O22, then you will have N2 dot. Okay, so N dot J in general, okay, below here it is your N dot J. So summation of the column, each categories for the column. So the first column here, the first category for the column, we have N dot 1. Dot means summation. So N dot 1 means that summation of the first category for the column variable. So we have O11 plus O21. Okay. N dot 2, we have summation of the second category for this column. So O12 plus O22. And then the total data here, we have N dot dot. So dot dot means summation, so total data. So the N dot dot here, you can calculate from here, N1 dot plus N2 dot, or you can calculate from here, N dot 1 plus N dot 2. You will get similar value because N dot dot is a total data. Or you can calculate O11 plus O12 plus O21 plus O22. Okay, so we will use this summation to calculate for the E. So here, because of chi-square test and because of we are dealing with the observed frequency, then still we have to calculate the expected frequency lah. Okay, but different formula for the expected frequency when we have contingency table. Okay. So this is a difference between contingency table and two-way ANOVA, because as you know, two-way ANOVA also with the row and variable. Okay, but I think the significant one, the table display frequency distribution of the qualitative data, but two-way ANOVA use some quantitative value. As we know, two-way ANOVA we have more than 2 data for each combination of row and column. Okay, we have replicate, so your replicate must be 2 and above lah. So that's why we have some quantitative value. So it is a significant difference between contingency table and two-way ANOVA. Contingency table, the data, the data that represent combination of row and column is a single data, but two-way ANOVA we have more than, we have 2 and above data lah. Okay. Difference between contingency table and linear regression. So the contingency table, the variable that you have, it is neither independent or dependent. It is not independent or independent. But linear regression, one of the variable that we have is a dependent. One of the significant difference between contingency table and linear. And another one, contingency table we cannot use for the prediction, but linear regression we can use for the prediction. So why we compare with the linear regression? Because based on the contingency table, we also test for the independence. So the independence here means that the relationship between row variable and column variable. That's why here we compare with the linear regression, because linear regression it is about relationship. Okay. But linear we can use for the prediction, but contingency table we cannot use for the prediction. Okay, so that's a significant difference. Okay, so we go to the first hypothesis here, 6.2.1, testing for the independence between two variables. So the objective is to find out whether or not the two categorical variables are associated with one another in a single population. Okay, so the data that you have coming from single population. Okay, so associate means that independence or relationship similar. Okay. So the test statistic is a chi-square test. It has been mentioned before this. We are using chi-square test. Okay, the formula similar as a categorical data. It is about O minus E square divided by E. Okay. Okay, the formula how to get your E here, the expected frequency. So the E here coming from this summation value. So Eij. Okay, for the first Eij, it is an Ni dot times with the N dot J divided by N double dot. Okay, let's say that we have O11, we need to calculate for the E11. So we substitute I here with the 1, J here with the 1. So to get E11, it is a N1 dot here times with the N dot 1 here and divide by N double dot here. Then you get your E11. Okay, I forgot to mention, for the contingency table, there is no assumptions for the E. So E can be less than 5. Okay, E can be less than 5. It can be less than 5. No need to do anything because there is no assumption for the E for the contingency table. Okay. Okay. So procedure for the independent test. Because of hypothesis is still 5 steps. Okay. First, formulate the hypothesis. Step 2, compute the test statistic, which is a chi-square test. And then, but before we calculate for the chi-square, we have to calculate what is our E by using this formula. Okay, by using this formula. And step 3, find the critical value. So the formula for the critical value. So the whole chapter 6 is about right theta. So still right theta here. Then chi-square here. The probability value is alpha. Degree of freedom, it is R minus 1 times with the C minus 1. Number of category for the row minus 1 times with the number of the category for the column minus 1. Then you get your degree of freedom. Step 4, decision based on right theta. Step 5, conclusion. Okay. For the independent test, what is your hypothesis? Okay. For the independent test and also the homogeneity test letter, your hypothesis is fixed. Doesn't matter what question that you have. Okay. As long as it is an independent test, your H0 will be the row and column variable are independent. Or you can use not related. Or you can write row and column variable. There is no relationship between row and column. Also correct. H0 is about they are not related to each other. They are different to each other. That's why independent, not related, or no relationship. H1 contradict to that. H1, it will be always the row and column variable are dependent. If you are using independent here, then the contradict is a dependent. If you are using not related, then contradict to that is a related. If you are using relationship, then contradict to that is a relationship is exists. Okay, so it doesn't matter what question that you have, this is your hypothesis. Okay. Again, the example here. So you have the contingency table, the data will be in this form. Okay, you will have the data below shows the number of insomnia patient. This is the number of the insomnia patient according to their smoking habit in Malaysia. Okay, at alpha 0.01, can we say that insomnia is independent with smoking habit? So the keyword here independent, then you are dealing with the independent task. Okay, or maybe you have like not related, also independent task. Okay, or you have like, can we say that there is no relationship between insomnia and smoking habit? Also independent tasks. Okay, they are similar. Okay, so the row variable here, it is between insomnia or not insomnia, and the column variable here is a habit, smoking or not smoking. Okay, so means that the R equal to 2, we have two categories for the row, and the C equal to 2 also, because we have two categories for the column. Okay, so step 1, hypothesis. So H0 fixed already. Insomnia is independent of smoking habit. Smoking habit. Okay. So the hypothesis here, you can follow the keyword in your question, or you can use the not related or relationship. It's up to you. Okay. Any keyword will be accepted as long as it is correct. Or you can talk about affected or not. So H0 it is not affected lah. Okay, H1 affected. So to be easy, you just follow your keyword in your question here. So insomnia is independent of smoking habit, and H1 insomnia is dependent of the smoking habit. Okay. So you can calculate the summation value here to find your E. Okay, it is not compulsory to write in your answer scheme. It is for your reference. Okay, and then after that you calculate for the E, because we need E to calculate for the chi-square. So the first column here is a observed frequency from the data here. Okay, the second column here, that's your E. Okay, so the E here, E n I dot times n dot j divided by n double dot. Okay, the formula here. And the third column here is a formula for the chi-square. So your chi-square is a summation of the third column here. Okay, we as a lecturer will be grateful if you can write your answer in this form. Okay, it will be easy for us to mark later lah your answer. Okay, when we go to the final letter. Okay, so please write your answer in this form in a column here. Okay, so easy for us to check and mark your answer. Okay, so the E here, there is no there is no assumption. So E can be less than 5. Okay. So after that, find your chi-square test, step 3, critical value, step 4, decision, and step 5, conclusion. So the conclusion here, you can write which statement that you support. So here, reject H0 means that we support the H1. So you can write here, at alpha 0.01, insomnia is independent of smoking habit. It will be accepted. Okay. So the next video I will discuss the exercise 6.2.1. Okay, so we go first to the 6.2.2, test of the homogeneity proportion. Okay, homogeneity here means that similarity of the proportion. Okay, so we are testing for the similarity of the column variable, or we are testing for the similarity of the row variable. Depends on your question. Okay, so the homogeneity test concerns on the homogeneity or similarity of the two or more subgroup of the population proportion in the single categorical variable with regard to the distribution of a certain characteristic. The procedure for the testing of the homogeneity, of proportion, similar to the procedure used in the test of the independent discussed earlier, except the hypothesis statement. As I said, for the 6.2 here, contingency table, doesn't matter what hypothesis that you have, step 2, 3, 4, they are similar. The difference is on your hypothesis and also conclusion. Okay. Okay, so the difference between homogeneity proportion and also hypothesis testing for the proportion. Okay, so homogeneity used if the response variable have a several outcome categories. So we have 2 and above lah. Used when the response variable has only 2 category as outcome. Okay. So proportion only 2 category lah, 1 and 2 category. Used when we wish to compare 2 or more group of population, and used when we are comparing 2 groups only. So that's for the portion we have 2 groups, but the homogeneity here it can be 2 and more lah. Okay. Okay, so the hypothesis for the homogeneity proportion. Okay, because of it is about similarity between the categories. Okay, so the subject, it can be row category or it can be the column category lah. Okay, row variable or column variable. Okay, so for the hypothesis here, it will be safe and it is a better to use the second one here. So H0, it will be always all proportions are the same. H1, it will be always at least one proportion is different from the another. Okay, why I say this one is safe for you to use. Okay, if you choose the number 1 here, you have to know you are comparing the row variable or you are comparing the column variable to know how many pi that you should write here. Okay, if we have same number of category for the row and column, then you are safe. Okay, same number of category for the row and column, then you are safe lah. Okay, doesn't matter the subject is a row, doesn't matter that we are comparing row or column, pi will be similar. The number of pi will be similar. If you have different number of category between row and column, then it will be quite dangerous lah. If you cannot distinguish, we are comparing row or we are comparing column. So to be safe, use a second one. Okay, H0, it will be always all proportions are the same. H1, at least one proportion is different from the others. Okay, so this is the example. No need to discuss the step 2, 3, 4. They are similar to the independent task. A researcher selected a sample of 50 seniors from each of 3 secondary schools and asked each student, do you come to your school on your own? The data are shown as follows. So it is a contingency table. The row variable here, the type of school, 1, 2, 3, and the column variable, type of school, and the row variable here, it is whether you come to your school by your own or you come to your school by, let's say, parents. Okay, with a parents. Okay, so thus the claim that proportion of students who come to the school on their own is the same for all schools. So the keyword here, same, homogeneity, similar, same, they are similar. They are homogeneity tests. Okay, so the keyword here is a same. Okay, it can be similar. It can be homogeneous. Okay, so they are similar. We are dealing with the homogeneity. Okay, they are similar keyword. We are dealing with the homogeneity. Okay, and then another keyword, proportion. Okay, then we have the homogeneity proportion. Okay, so for all schools, so the subject here is a column variable. We are comparing column variable between school 1, school 2, school 3. Okay, so H0, all the proportion are the same. H1, at least one proportion is different. So we are calculating all this summation to calculate your E here. After that, find your chi-square test. Okay, so how to find the critical value? Similar, it is R minus 1, C minus 1 for the degree of freedom, and alpha as your probability value. Step 4, decision based on right data. Step 5, conclusion. So for the conclusion here, similar, we write which statement that you support, H0 or H1. Okay. Okay. Okay, so I will discuss the exercise in the next video lah. Okay, so that you will be clear about the contingency table. Okay. Okay, 6.3, goodness of fit task and contingency table using Microsoft Excel. I leave it to you. Okay, you can go through the slide, you can go through your module for the goodness of fit and contingency table using Microsoft Excel. Okay, so I think that's it for this video. Thank you. Okay, sorry. This is a summary of the goodness of fit and contingency table. So you can read by your own. Basically, it just summarizes what we have discussed before. Okay, so that's the end of the chapter 6. Okay, so the next video I will discuss the exercise question for the 6.2. Okay, thank you.